Thermochemical equations show both the enthalpy change and the mass relationship for a given chemical reaction. For example, look at this equation. 2Na plus 2H2O reacts to form 2NaOH plus H2. The change in enthalpy in this case is minus 367.5 kilojoules. What this means is that minus 367.5 kilojoules is the enthalpy change associated with the reaction of 2 moles of sodium solid with 2 moles of liquid water to form 2 moles of sodium hydroxide and 1 mole of hydrogen gas. Note that since the initial and final states of a given reaction depend on the physical state as well as the chemical species that it is critical for thermochemical equations to include state symbols. Let's look at an example. Here we have the same thermochemical equation and we want to find the change in enthalpy associated with the reaction of 2.32 grams of sodium solid with a large excess of liquid water. This means that the sodium solid is the limiting reactant. The enthalpy change in kilojoules can be given by looking at first the amount of sodium solid. Okay. And then what this amount of Ng means is that this is the amount for 2 moles of sodium, and hence I need to convert grams into moles. 22.99 grams of sodium is 1 mole of sodium, and for every 2 moles of sodium the change in enthalpy is negative 367.5 kilojoules. As a result, the enthalpy change is minus 37.0 kilojoules. Now let's look at the effect of reversing the thermochemical equation and see how we would account for that when we determine the change in enthalpy. Here we have the same reaction, okay? 2 moles of sodium solid reacting with liquid water to form sodium hydroxide and hydrogen gas. This is the enthalpy change. This is akin to look at this. We have an enthalpy diagram here, and we have a higher enthalpy in our reactants than our products. The change is minus 367.5 kilojoules. Now, what if you do the reverse? We're essentially going the other way around. We're going upwards, and hence in the reverse reaction we are going upwards, and hence we just change the sign since we're doing the same thing but in the opposite direction. And the change in enthalpy for this reaction therefore is plus 367.5 kilojoules. When we change the reaction coefficients, on the other hand, we are changing the amount of stuff. Now, let's think about this. Let's take an analogy of buying stuff. It costs $1 for 1 hot dog. So it would cost $5 to buy 5 hot dogs. Similarly, if we change the coefficient, we are multiplying all the coefficients by a certain factor. And we have to multiply the enthalpy of reaction by the same factor. So in this case, we halved each of the coefficients. And hence, we halve the change in enthalpy, and we end up with minus 183.8 kilojoules as the enthalpy change.